Hi, welcome to another episode of the On.NET Show. And today we're going to be talking about async, await, tasks, asynchrony. And we've got Brandon Minnick here, who's one of our cloud developer advocates focusing on Xamarin. So how about you tell us a little bit about yourself and what we're going to be talking about today?
Sure, thanks, Rich. Yeah, my name's Brandon Minnick. As Rich mentioned, I'm on the cloud developer advocate team. So I have probably the coolest job in the world. I get to go around and talk to fellow developers, talk to them about all the cool stuff we do in Azure and Xamarin. I primarily focus on Xamarin. But yeah, today we're going to be focusing on some async and await best practices. You know, I was chatting with some fellow cloud developer advocates just a couple weeks ago, and we got into some of the nitty-gritty on async and await, and we said, you know what? This would make a great On.NET show.
Right. So actually, before we jump there, you know, so we've got, you mentioned Azure and Xamarin.
Yep.
And it's like, I just thought to myself, I always thought those had nothing to do with one another, right? One's about phones, and the other one's about the cloud. So what is the relationship between those two? Like, why are you joining them together?
Great question. So Azure can be used by anybody. So it doesn't matter if you have a website, a mobile app, desktop app. We can use anything with Azure.
Okay, but like, what would be kind of your poster child use case for, you know, if I'm deciding to go build an iOS or Android app with Xamarin? What would be the most common way that I would use Azure in my app?
So every mobile app, well, most mobile apps have some sort of remote backend. So where are you going to store some data in the cloud? Where are you going to have authentication? What are you going to log into? And we can do that all with Azure. And probably the best place to start would be Azure Mobile App Services. It gives you login capabilities, database functionality, push notifications. It's all just there for you.
I see. So it's basically the place to store my high scores if I'm building a game.
That's right.
Or like if I have users placing orders and on my inventory, then that's all related to the cloud.
Yep.
Okay.
Use the power of the cloud.
Makes sense. So now let's talk about async and await.
Yeah. So what I have here is a pretty simple app, and we'll include a link to the app in the show notes. And I love reading Hacker News every morning. So what this app does, it pulls down the top 20 stories from Hacker News. You can click on any of them to dig in more. But the code behind me is what we're going to be focusing on. And in Xamarin, we do a lot of MVVM. So that's model, view, model.
That's right. As opposed to MVC.
Yep.
That's kind of the other one, right?
Exactly. Very similar to MVC, but more V's, more M's.
Yeah.
And
more separation, really.
That's right. So you can see I have one called Bad Async and Await Practices, one called Good. And Rich, you and I are going to run together through the bad one and see if we can make it good. But first, I want to show off some slides here.
Kind of a primer.
Yeah. So these slides come to us from Xamarin University. And if you haven't tried Xamarin University, I'm a big fan of it. Go check it out. It's actually what I used to learn Xamarin. Years ago, I couldn't make a mobile app. Xamarin University took me from zero to mobile.
Very good.
Yeah. And what's also cool is they have a whole C# track. So even if you don't know C#, you can start with C# 101, take all the C# classes, and then get into mobile. And so this is where these slides come from, is from the async and await class in Xamarin University. Now, what we're looking at here is just a pretty typical async method. It creates a new web client, downloads some data, transforms that data from a byte array to a string, and then executes the load data method. But what I didn't know was that this is actually what the code looks like when the compiler actually boils it down into the IL. So what really blew my mind here, Rich, was it actually creates a class. So I didn't create a class. I created a method with maybe 4 lines of code, but look at all this. We have a sealed class, compiler generated, that implements async state machine, and all those variables we have in our method are now fields. So if we look a little closer, we're able to see that the variables we created are still in here. So we have our string data, we have our byte array result, our web client, and even the URL we pass in is a field. And looking down a little further under the methods, you'll see one called move next. Now, I bet most developers have seen move next probably in their stack traces.
Right, and it's mostly the place where most people see that come up is with IEnumerable, with like for each.
Oh yeah, or anytime I get a crash from an async method and I go through the stack trace, it's move next, move next. And I'm like, what is this? I never created move next. So let's check that out real quick. So move next is essentially just a giant switch. And what it's doing is maintaining the state of our async method so that we can actually have the thread leave the method, and then when it comes back, everything is exactly where it left it.
Yeah, I mean, this is a state machine.
That's right. And so what's kind of cool is every time we call await, there's going to be another state in move next. And so in this case, we have all the code for initializing the web client, downloading the task, and then what it does is it actually moves to the next state. And so we're going to actually leave this method, and when we come back, we'll run the remainder of the code.
Yep. And then to me, this sort of code gen makes sense. So I first ran across something like this, and I think like the .NET Framework 2.0 days. I was really interested in anonymous methods, I think it was.
Okay.
And so I looked at the C# that was generated. I mean, it was really the IL that was generated, but I was using Reflector, so it generated C# for me to look at. And yeah, it generated this class that kind of helped encapsulate something. And so it's the same thing that's going on here, which is you basically have some method that you've called, but it has a lifetime that's effectively longer than just a single method call, even though it just looks like a method call. And so the only way to encapsulate that over time is to create an object which has all of that data and that behavior that you need. So that's kind of what's going on here.
Yeah, exactly. Couldn't have said it better myself. Oh, and actually one more thing. And if we look closely, you'll see all of this is wrapped inside of a try-catch block. And this was something that surprised me because I'd always heard you should always await a task. You never kind of want to do a fire and forget task, but I never really knew why. Well, this is why. Because if an exception is thrown inside of your async method, it's going to be caught in this catch block. And the only way to rethrow that exception is by awaiting the task.
Right, so it effectively becomes part of the contractor protocol between you and the method you're calling. If you want to participate in everything that async, await, and task have to offer, then yeah, you need to participate, which is by using these keywords.
That's right. So I tell you what, Rich, now that we are async await experts,
yeah, we're totally schooled.
Let's dive into some code and see if we can make it better.
I guess the one thing, and this is probably super obvious, but for me, the poster child example of why this even exists is when you have a client app in particular, although there's lots of cases on the server too, but I'm going to ignore that right now, is in a desktop app or a mobile app, you want to avoid the screen freezing.
Yes, that's the biggest thing. Mobile users in particular, very, very fickle.
Yeah.
Think about the last time one of your apps froze. We force quit it, we relaunch it.
Totally.
I don't have time for that.
Zero patience. So anyway, this is the primary problem that async await solves.
Right, because your app's UI is all done on thread 0, which is also called the main thread. Mm-hmm. And so if thread 0 is constantly downloading data and doing these long-running tasks, well, now your UI can't update.
Yeah.
So users go to tap a button, nothing happens. Go to swipe, nothing happens.
Yeah. Makes sense. Okay, let's take a look.
Cool. So what I've done here, I've got a bunch of to-do comments. And so this first one, we're inside of a constructor here. And I'm calling task.run because I want to refresh the data in my list as soon as the app launches. But as we know, constructors can't have async and await inside of them. So what I did here, I'm calling task.run and kind of doing a fire and forget. Now, what's bad about this?
Well, the first thing that comes to mind is you are doing a fire and forget, but you don't know when that's going to finish. So wouldn't you want to stash away a task somewhere so that in the actual instance methods that you have there, that you could put in a wait at the start just to make sure that that work had been done?
Yeah, exactly. And also, what happens if an exception gets thrown inside of here? We're going to lose that too.
Yes, definitely.
So the way I like to do it is just below us, you'll see I have a refresh command here. And what I like to do is, let's get rid of that. And
oh, the answer just could have been deleted. Oh, how did I not know that? I'm guessing that wasn't it.
Yeah, no, I like to do commands.
Okay.
So this command down here actually does the same thing. Commands are meant to be fire and forget. And yeah, we never have to worry about when that task finishes, if there's an exception thrown. It's all handled for us inside of the command.
Okay, now I kind of know what commands are. I've used them a little bit, but this is now we're fully getting into the MVVM model. Commands are part of that, right?
Yeah, commands are used pretty heavily in MVVM.
Yeah, so help me understand. So refresh command, that's basically what this method is that you have on line 27. Help me understand what null means in that case. What might I have passed other than null? What's the meaning there?
Oh yeah, good question. So you can actually pass in parameters to commands.
Okay.
And so right here, if
or what if I had not passed anything in there at all? Does it require some state? Okay.
It does require an object.
Okay, so that's where we have a null.
So it looks a little funny to pass in null, but we could also have it pass in. We could do something like this, where we are passing in a string called title. And so that's where we could take advantage of passing in those parameters.
Got it. Makes sense.
So little goofy looking, but now we've kicked off a command. Our data is going to refresh, and so let's keep going. I think we're doing an awesome job so far. Okay, so right here, now we're saying we're refreshing the data, and we're set is refreshing to true, but we're saying .wait. What's bad with this?
Right, so here we're going to be blocking.
Exactly.
Right, so we're basically getting zero benefit for async await at this point. So I assume set is refreshing is returning a task.
It is.
Yeah, so then it feels like we should await that.
Yeah, totally. So the best answer is to await it, but I also kind of want to throw another question at you. What if we have to run this synchronously?
Meaning that you want to block effectively. Is that what I hear you saying?
Yeah, so I'm going to come back to using await, because that's definitely the right answer.
So are you saying that, do you want...
Have you ever used get await or get result?
Not too much. I think you're going to have to go into this pattern.
No problem. So getAwait or getResult effectively does the same thing as .wait. It's going to block, but it will unwrap the exception if an exception is thrown inside of this async method.
I see. So if you just do .wait, obviously that blocks. Are you saying that if there was an exception thrown in the underlying task, that it wouldn't be bubbled up with .wait?
Exactly.
Okay.
Yeah, so my rule of thumb is never, never, never use .wait. And we'll get into .result too later. But yeah, if we have to do it synchronously, getAwait or getResult is definitely the right way to go.
Okay. Now, in this particular case, I think this would only be appropriate if we knew that the the task was fairly short-running in nature, meaning if this was a long-running task, then this would be a bad idea, right?
Yeah, always push it to a background thread. So on mobile, the rule of thumb is if it takes longer to run the task than it does to refresh the screen, do it on a background thread. And so typically that's 60 hertz refresh rate. I think even the latest iPads now do 120 hertz refresh rate. So you can do the math and figure out you don't have a lot of time.
No, that's quickly getting down to like the 10 millisecond territory.
Oh, yeah. All right, so let's put that back, because you were definitely right the first time.
OK, good. So I'm passing grades still?
Oh, flying colors. Now, this next one's a little tricky, because we're using await, so that looks good. But how could we make it better?
Well, I think, let's see what this method is doing. So it's returning a task. Oh, we could just, so top story list. Is top story list an instance property or field on this class? What is that thing?
Yeah, top story list, it's the list of stories. It's a property in the class. And oh, I should also give you another hint. Nothing in here is touching UI.
OK.
So this is all business logic, and we don't need to return back to the main thread.
OK. So couple thoughts.
Mm-hmm.
I guess the first thought is it necessary to actually await this at the moment? Meaning, could we change the type of top story list to be task of whatever? Because then we would be able to just do the assignment there immediately and not await.
Interesting. In this case, we do have to await it.
OK.
Just because this is how the view model is propagating back up the data.
So we're basically going to data bind against top story list.
Yep.
Right. So then it definitely can't be a task. So I'm not too sure about your hint, which is that, OK, ConfigureAwait equals false.
Yeah.
So this is something that's done in libraries a lot. And yeah, how about you explain to us what
Sure.
this is doing?
Yeah, so when we come into this method here, let's say thread 0 kicks off the execute refresh command method. So thread 0 is going to come in here, and thread 0 will get to this await get top stories. When it gets there, await tells thread 0, hey, you can go back and continue what you're doing.
I remember what ConfigureAwait does. It basically says don't transition to another thread. Is that what that does?
Yeah, it lets you keep using the thread that executed this method.
Exactly.
So what's kind of cool is, so normally thread 0, we'd release it. Thread 1 would start getting the top stories. And without ConfigureAwait false, when thread 1's done, it has to call back to thread 0 and say, hey, I'm all done. You're back up. And then we have that context switch. We're back on thread 0, and then thread 0 finishes out the method. But with ConfigureAwait false, what we're saying is, go ahead and let thread 1 continue. So thread 1 gets the top stories, and then when it's done, continue on thread 1 for the next few lines of code, or actually for the remainder of the method. And that way you avoid that context switch and save some time and boost the performance of your app.
I see. So you're saying we'll do this try line 51. We'll complete it with ConfigureAwait, and then we'll get down to line 56, and we won't have transitioned back to the main thread yet.
That's right.
OK, makes sense.
Yeah. Now that was the reason I gave you the hint about needing to update the UI, because we always want to update the UI from the main thread. So if the next few lines of code needed the UI thread, obviously we'd want to avoid ConfigureAwait false.
Makes sense.
But in this case, we can get some performance out of it. Cool. So the next one, we already hit on this one. So as long as I can spell it properly, we can get through that one pretty quickly.
Yeah. So one of the things I do in the code that I write in, it's obviously not fully appropriate here, but there's this case where you feel like you have to write await after every single method that's task returning. And in some cases, what you should just do is make that method return task of whatever, and then just return. And not await. It's like let your caller decide how to handle that task. You don't need to.
You're totally right. And actually, you read my mind, because down here, we were going to do just that.
Okay.
So I'll tell you what, Rich. How can we refactor this method?
Right. So this one's already returning task of list of string. Right, and that's basically what that thing returns. So if we just remove the await keyword, it should then satisfy and remove the async line. Then you're good to go.
Yeah. This was one that was really cool to me that I wasn't aware of.
Yeah.
But yeah, after we looked at, we dove into the IL earlier. We saw that class that gets generated. That's a couple hundred bytes. We can save all that performance impact by just returning the task.
Right. Yeah, so one of the things, I've been lucky working on the .NET team. I have all these task experts around me. So whenever I've written samples, I usually get this guidance hammered into me.
Yep. And so this is one of my favorite things to do now. But I will tell you, I took it too far. And that's why I have this method right here, because similar story, we're calling this method that returns a task of story model. So why not just do this like we did above?
Right. Right. Makes sense.
But the difference is now this method will return right away. And if there is an exception thrown, it's not caught in my catch block. So it's almost like this catch block doesn't even exist, because if an exception gets thrown in this method, we're already done with this method and we've already returned. And this actually hit me is I was trying to debug some code and I'm like, why isn't this working? And it was because I wasn't awaiting this here. And while we're on the topic, another gotcha is if we were inside a using block. And so if we needed to use this memory stream object, well, again, this is just going to return right away because it's returning the task. So if we find yourself inside of a using or inside of a try catch, then you actually do want to return await.
Right, right.
So forewarning, learn from my mistakes.
Yeah, the other situation that I've been in is if you have an if statement, one side of the if, it's perfectly fine to return the result right away. But the other side of the if, for whatever reason, you need to be more, inspective. And in that case, you need to actually look at the data to decide what to do next. That can cause this challenge where you kind of have to go one way or the other, even though, in those cases, you'll probably end up going the async way, just because you do have to do this work on one side of the if. So sometimes the methods you write are not completely uniform in nature with respect to handling. OK, well, this is great. I feel like we've gotten quite a bit of a lesson here.
Yeah, thanks, Rich. And I'll throw up the summary slide.
Yeah.
So this is kind of what I learned. And so for me, never use .wait or .result, because getAwait or getResult will actually do the same thing if it has to run synchronously. The only difference being getAwait or getResult will actually rethrow that exception if it exists. Now, obviously, if we're doing asynchronous code, always use await. That should be a no-brainer.
Right.
And yeah, we can use ConfigureAwait false when the calling thread isn't needed. So for example, in MVVM like we did today, there's no UI going on in the view model. So ConfigureAwait false everything. And then the last one, avoid that return await. So if the only place we're using await is in the return statement.
That's kind of the case we were just talking about.
There you go.
Definitely.
And then, don't do it inside of try catch and using blocks. Otherwise, you'll spend hours debugging your code like I did.
Right. So kind of into the closing thoughts. Obviously, we shipped Task, I think, in the .NET 4.0 timeframe. and then we shipped Async Await in 4.5. So it's starting to be multiple years since we built this technology. And with some tech, it's really important for a period of time and then kind of falls away. With this one, I feel like it's really just kind of embedded itself as just a core piece of the platform. And developers who are using .NET 5 years from now are just going to be learning this tech and just using it as a matter of course. Do you agree with that?
Oh, 100%.
Yeah. Okay. Any closing thoughts from you? Maybe kind of tying this back to Xamarin in some way?
Well, there is one more thing I want to touch on. I don't have an example of it in the code, but ValueTask. So let's say that we have a method that sometimes needs to await, but sometimes that the result of the method is just ready, and we can return it right away. So in this case, I could see I go to update the news list, but maybe I already fetched it. Maybe it's already there waiting for me. You can actually use ValueTask, and that avoids all that overhead that we saw of creating that compiled async method with the iasync state machine.
Right. Well, there's two parts. One is what you just said, and the other one is it's a struct, so it's on the stack instead of allocated on the heap.
That's right.
So it doesn't bother the garbage collector. So in cases where, particularly if you're in a tight loop, where that data is almost always going to be available, then yeah, ValueTask is pretty attractive.
Yeah.
Now, could we have used that in this particular app, or is it more for other scenarios?
Well, the way I architected this one, no. But the most common place where I've used it is for databases. So in the Xamarin world, we like to use SQLite. And those databases need to be initialized using an async method, but only the first time. So the first time we hit it, yes, we'll have to await the database initialization, but every time after that, it's already there. So
right.
I actually went through all my old code this weekend, refactored it using ValueTask, because it's already there waiting for me.
Right. So were you able to measure that difference?
I did not, but I'm putting it on the to-do list for you.
Okay, well, this was a great conversation. Async Await and tasks is always a fun topic to get back to. So thanks, everyone, for watching the On.NET show. Hopefully you learned a few more things about one of your friends' tasks and Async Await, and hopefully you can find some opportunities to use this guidance in your own code. Thanks.